Hello. Today we'll be explaining the problem Angry Cows from the USACO Bronze competition. Let's get right to it. So let's read the problem first. Bessie the cow has designed what she thinks will be the next big hit video game, Angry Cows. The premise, which she believes is completely original, is that a player shoots a cow with a slingshot into a one-dimensional scene, consisting of a set hay bales locating at various points on the number line. The cow lands on a hay bale with sufficient force to cause the bale to explode, which in turn might set a chain reaction that causes additional nearby hay bales to explode. The goal is to use a single cow to start a chain reaction that detonates as many hay bales as possible. There are n hay bales located at the distinct integer positions x1, x2, all the way to xn. On the number line, if a cow is launched onto a hay bale at position x, this hay bale explodes with a blast radius of 1, meaning that any other hay bale within 1 unit of distance are also engulfed by the explosion. These neighboring bales then themselves explode all simultaneously with a blast radius of 2. So these explosions may engulf another additional yet unexploded bales to up to 2 units of distance away. In the next time step, these bales also explode, all simultaneously with a blast radius of 3. In general, at the time t, a set of hay bales will explode, each with a blast radius of t. Bales engulfed by these explosions will themselves explode at time t plus 1 with a blast radius of t plus 1, and so on. Please determine a maximum number of hay bales that can explode if a single cow is launched onto the best possible hay bale. So the input will just be n, and it'll be within a billion, or yeah, that's a billion. So we're gonna have to use long, I believe. Yeah. Please output the maximum number of hay bales that a single cow can explode. Okay. So that means there's gonna be six blocks. So the lines contain integers x1 through xn. Okay, now let's see what we do. Oh, I'll explain the problem now. In the problem, we have like a set of hay bales placed along a number line. So let me just open Paint real quick. So imagine this is our number line. Oh, this is our number line. According to the thing, we have let's plot our points. 8, 5, 6. It's 8, 5, 6, 13, 13, 3, 4, 13, 3, 4. So it's 3, 4, 5, 6, 8, 11, I think. 11, and these are just the points, and yeah. We have a set of when one explodes, it causes like the ones around it. So I'll show another diagram. So say there's a hay bale here, 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 and let's just do this until there's a 4x4 row, I guess. Exactly, good. So if we explode this one, then that means ones around it are gonna explode. So this one, 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 because there's a radius of just 1. So since all of these values are 1, it explodes. And then this one, since it is a simultaneous explosion, as it'll have a blast radius of 2, so it'd be this and this one, if there was one there. So it'd be explode here, here, here. Yeah. So it'd explode a lot of it. So pretty much a third chain reaction would explode 3. Okay, now when we simulate the process of like a single hay bale exploding, we can just separate the explosions into 2 separate explosions, one that goes to the left of the number line and the other that goes to the right. For the explosion that goes to the left side, we can for the one that goes to the left side, uh, So if it does explode, then we only need to consider the left side, and that way the radius will increase by 1. But if the hay bale just exploded, then it'll be at least 1. Because of this, when a hay bale explodes, we can fix the direction of the explosion. For any given hay bale, we can find the hay bale furthest from it, and it would be caught in the explosion. After we've done this, we can then just simulate the exploding within a radius. Now then let's start coding it. Let me just reset my code real quick so we can start on a clean slate. So this is just Eclipse. Use anything you want, and let's start. So let's just add IO. So let's import IO. And now let's add our public static void. Public static void main string says it's just basics of setting up Java program, and we'll probably be using just buffer reader and print writer because it's USACO, and yeah. Oh wait, I did it right, yeah. Oh, whoopsie, I guess I already had it done. Okay. This is always annoying, but it's something you have to do. So the file name here is gonna be angry, so make sure to, it says it's gonna be angry here, so make sure to use angry.in and angry.out. No, that's just buffer reader. Now let's do print writer. Oh, I hate writing this. New buffered writer angry.out. What did I do? Oh, whoopsie. Oh wait. Shoot. For print writer, you can't just do immediately angry.out. You have to use file writer after that. So let me just do that real quick. Okay. Oh, and then we have to do the declaration. File not found, and IOE. So yeah, that's good. Now we can do our actual code, which is always more fun. So int n equals integer dot parse int int n equal n equals integer dot parse int, it'll be br dot readline, because it said that the first line would always be how many x values there are. So n, so we'll write here, n is the amount of x values. So yeah. Okay, now let's make our array. So loc will stand for locations. Now these will be the x values of the things. Now let's just add that to the array. Since we already discussed most of the logic, this part should be much easier to solve. Yeah, that's good. It's also much more convenient that, oh, I did it in the wrong order. Shoot, my bad. Also much more convenient that it's in each line, so we can just use read line every single time, pretty much. Okay, now let's sort it to make it an actual number line. Raise dot sort lock. Okay, now let's create a result value, and let's start the hard part. St equals 0. So this will just loop over every possible like hay bale, like which will simulate the explosion. So let's just write this. Loops every possible hay bale which simulates, which does the explosion, shows the explosion. Okay, now that we got that out of the way, now we'll do left for, as we talked about the left value and the right value. So now we'll be creating another function soon, and we'll be calling this one probably just x ind idx. So it'll be x idx. Oh, it's gonna be hard to remember. I'll just copy paste this for future reference. So this will just be a thing we'll do, and it'll have let me think. It'll have an array, an integer, and a boolean for our three values. Yeah, we'll work on that later. Now let's figure out rightmost value. Yeah. Yeah, we just do this one for false value. And we do the number of exploded, which just is r minus l, so it's right minus left plus 1. Which should make sense because right is like the most and then left is the least, so yeah. Now if it does explode, if our total number is greater than our current answer right now, then answer should be it, because like if we explode more hay bales, then we should update that. So num is greater than res, then res is equal to num. Okay. Now that's the end of our static void, and the real like hard coding starts with the other part of the function. So it's pw.println, and it'll just be res. Now we close it for good standards. So now let's start our harder part. Public static int x index, the explosion index, and then int lock int st and boolean l. We'll just call it l. Now let's make the current radius, because we want to change the radius each time to see if we can change it. So let's just make a current radius. So what should we call it? C-rad? Yeah, whatever. C-rad. Okay, that would stand for current radius is equal to 1, because the radius always starts at 1. We'll have the last explosion index, and that'll start with the start index. So yeah. Now let's start the while loop. So if it's either not the left or the right, then we just keep on looping through it. That's why we're using a while loop. instead of for loop, for example. So then last is greater than 0, and it can't be or, cause yeah. Oh yeah. Okay, so last has to be greater than 0, and last has to be less than length minus 1. Okay. Now we'll create the direction. Okay, now we need a. So we're setting direction so we can find like if left is if our boolean is true, then we can if it is true, then we go backwards 1. If it isn't, we go forwards 1. So yeah, there goes 0. Now our boolean is called L, right? So if L equals to true, then that would be. Oh wait, we don't need curly brackets for this one. There equals -1. Else there equals 1. Yeah, that's our direction. And then now we gotta do our next index. So we'll call it int idx next index. Well, it'll just be the last explosion, so it'll be last. Now this is the long part of the code, but pretty much it's kind of complicated. Pretty much what we want to do is check if the closest hay bale is within the range of the explosion. And then we do that by checking the index, which is next index plus the direction. So like since we don't want an error in our code, we have to check between 0 and length -1, because if it was just the length, then it'll be over 1, which would make it index out of bounds. After that, we check the distance between the 2 points and see if it's like less than or equal to the explosion radius. So let's just try to do this. Maybe we should just rename it to X. Oh, next index. Next index plus dir is greater than or equal to 0. Then we also want idx plus dir is less than location dot length and math dot absolute value location of next idx plus direction minus location last, and then wait, let me think for a second. So we did 3. Now wait, yeah, I remember now. After we do location last, then we just compare that to the radius, or the current radius, so crad. And yeah, that's our long thing. Oh wait, did I